Yep.
Okay.
So if anybody shows up, it will come like a small picture window here.
Okay.
All good?
Thank you.
No problem.
Hey Jason, how's it going? Long time.
Yeah, it's going. Going busy.
I'm busy.
Nothing new, right? All stuff.
Yeah, it's all stuff. Pretty happy this time.
So you're reading something about Walker separation?
This is Harley.
Harley's, okay.
Harley's. So review paper on the position of ITCC,
Mhm.
the mean position of ITCC.
Is Sarvana going to be here or not?
He left. He was not here. He left away today. Left around 3 o'clock. I don't know. Hello.
Hello.
So he buy me park?
No, I didn't buy any car.
No. I don't.
Sarvana.
You don't know.
No.
Yeah.
Oh, did he buy any car?
No. Actually, he was driving a really old video, right? So I know the place he parks. It's a new, it's a Camry now. So last day I asked him, and he said the old car kind of broke down, and if you want to fix it properly, you have to spend a lot of money.
But he already had a Camry. He also had a Camry.
So that's his wife's car. So that's the one he used right now. So he's kind of deciding between whether to spend money for fixing the car or buying a new one.
Okay.
Then I received sort of a brochure from Honda by mail. So I just took it and kept it in my office. Like if I see my
I think he might.
I was kind of surprised, like, that car is 15, 16 years old.
The Sienna.
Yeah. So it's kind of rare, like, these faculties have any decent amount of money, right?
Yeah. Like I think for some people.
Some people are very picky about cars, like they don't want to spend any dollars on the car. They just need to get something that will transport them from point A to point B. That's it.
Yeah.
Nothing. No fancy things at all. People are very specific about these things.
Yeah.
Have you guys met the new visitor?
No.
You both were not here, right?
No, I've seen him.
Oh, you have seen him.
Yeah.
Okay. You were not here last week, or the week before.
Yeah, the week before, I guess, yeah.
And Dr. He is from Hangzhou, China.
What's the university? No.
No, it's the second institute.
Uh-huh.
Oceanography Institute. So
So,
he's going to be. He's very interested in the near initial oscillations.
okay.
Jason is our expert of ROMs.
Wow.
ROMs simulation, ROMs model. So if you want to use the ROMs and have technical issues, most likely Jason will be able to help you.
Nice to meet you.
Nice to meet you too. So you mean you stay US for the first time?
First time to the
First time doing this?
Yeah. Hi.
First time, okay. How do you like it so far? Good?
Little bit happy to try the weather.
Oh, yeah.
Thank you. Which one? This one? Frank?
Right? Sarvana is coming, right?
I don't know because I saw him leaving with all his bag around 3 o'clock. I don't know whether they went.
family issues. All right, it's okay, but is Chris is gonna be here, right?
She's
Yes,
not here
Chris.
yet.
Okay, just wait, maybe we'll give Chris a few moments.
Okay.
Okay. Did you remind her? today?
Nope. But I sent out an email, so I mean, with my proposal, so I suppose she know that I'm,
Presenting today?
yeah.
Okay. Maybe we'll wait for a few more minutes.
Okay.
Have you announced the president already? You have not. Well, you need to do that pretty soon. I mean.
I guess it might be.
This is what your, this is your fourth year.
This is, I finished my 4th. This is,
The fifth year.
it's good.
Wow, definitely should.
Yeah, so Simon thinks I should defend end of this year,
Within this year,
end of this year.
end of this year.
So I think I have to do it sometime in summer.
Oh, Sam is doing online.
Oh,
Well, Sarah is joining us at home.
is that a,
So I think he's in his car.
In his car?
Yeah.
Yeah.
Yeah, right.
You're gonna join us in, my God, he is?
Maybe
Well-
he's doing it from his phone, I guess.
What is he doing? What?
I'm picking up the. I picked up the interview candidate. That's why I'm here.
Are you sure you want to drive? That's why you're driving?
No, I'm not driving. I parked here. She's talking to somebody at the School of Public Health. So I just thought I have 15, 20 minutes to go before I pick her up.
Okay,
Okay.
all right. Okay, that's fine. I saw you were driving. That's not a good idea.
No. I'm not that.
Okay.
Yeah.
All right.
This is also
Yeah,
there, I guess.
Chris is there too. Oh, but I think Chris is on, right?
Yeah, I think Chris here.
Yes, you just-
Chris, are you with us? Can't hear from
Oh, yeah,
Chris.
that's better.
All right.
Okay.
We can go ahead. So Wei Qing is going to give her a practice presentation on her premium later this month, right? In
Yeah,
2
like-
weeks,
In
In
10
2
days.
10 days. Okay. All right.
So this will be my practice presentation on prelim. And since I'm still revising my proposal, so I might have a lot of problems in my presentation, so just let me know if you have any suggestions. So my topic is on quantifying the impact of sea surface temperature biases on interannual variability and seasonal predictability of simulated tropical cyclones. And I will start with the background and objective, and then address some scientific questions and give some hypotheses on the questions. And then I will talk about my research methods and a little bit of the preliminary results, and then I will end with research timeline. So one of the reasons that we choose this topic for my proposal is that the tropical cyclones are one of the natural hazards that strongly influence the life and economy. For example, we all know that Katrina and Sandy are one of the most destructive and deadliest tropical cyclones that hit on the land of the U.S. Improving prediction and future projection of the TC activity is one of the highest priority research areas. The projection of TC activity under future climate scenarios have been under debate for some time. But now, since the improvements of computational capability, people start to use high resolution models to do the projection. So an emergence of consensus regarding some aspects of the future TC projection kind of occurred. So now we expect to see a slightly decreased number or frequency of TC in the future, and as well as an increase in the intensity of TC. But we have no idea how the location of TC will change in the future. For example, we don't know how the track of the TCs or how many percentage of tropical cyclone will landfall in the future. And also, we have no idea how the sub-region's TC activity will change in the future climate scenarios. So further research on providing more reliable climate model simulations of TC for future climate change projection is still needed for both scientific and community and society. Other than the future projection of TCs, the seasonal forecast of TC activity is also really very important. It had been started in the early 1980s, and people have been using statistical models. But nowadays, due to the improvements of computational abilities, people now use dynamical, either atmospheric only or coupled atmosphere ocean models to do the forecast. For example, Zhao et al. In 2010 used a high-resolution atmospheric only model with two different kind of SST to prescribe. The first data set is observational SST. The other one is the persist SST, persist in June. So they found out that the SST can be one of the most important variables that influence the TC forecast. And in their studies, they use SST index, which is the relative change in SST in the main development region of TC to the tropical mean SST. And they also mentioned that this might be a good index to quantify how good is a couple model to forecast, to do the TC forecast. Because when we use couple model, we don't have prescribed SST, so it will be really important to know how good is the model to predict the SST variability. And Becky et al. In 2014 demonstrate that there's statistical dynamical hybrid system, which they call hybrid hurricane forecasting system, can be better than dynamical model only forecast, at least in the North Atlantic regions. And they also mentioned that it is really important to find out aerial models to quantify the uncertainty in the models, other than just use the internal variability, which is the inter-ensemble spread. So in their studies, they use the ensemble means as their best estimate, but they mentioned that we should find out error models to quantify the uncertainty, but they didn't mention that what kind of error models might be useful. So as I just mentioned, SST is really important to TC activity and the simulated TCs, and we also know that SST can influence the TC development both locally and remotely. So locally, when we have higher SST, we tend to have more active TC activity. and remotely, for example, in the Atlantic region. So if there's a change in the southern Atlantic SST, it can be influencing the North Atlantic TCs through the change in mid-troposphere humidity and wind shear and so on. And Webster et al. In 2005 used a future projection.
Chris complaining that it's not broadcasting. Can you-
I think it's here.
No. What is these things?
Oh, I just used to do the mirror control the display.
It's not here. It is broadcasting.
Saravanan is on there, right?
Yeah. Sharon, can you follow the presentation?
No, I can't see it either. I was just listening to the audio.
Oh, you can't see it?
No, I cannot see it. I can hear the audio, but not see it.
But here it says it's sharing the screen.
Okay, now I see it. Now I see it.
Okay.
Yeah.
Chris, can you see it now?
Chris is trying to log in.
Anyway, I'm going to be signing off. But
Okay.
it's coming through now. It's coming through now.
Okay. Okay. All right. I think you can go ahead.
Is Chris on?
You have to wait for her.
Logged out and logged in.
Oh, I can ask her to try again.
Okay. It's on there.
Hello, Chris.
Hey, can you guys hear me?
Yeah, we can hear you.
Okay, yeah, I can see it now.
Okay, you can see it now. That's good.
Okay.
All right.
All right, thanks, guys.
Okay. And you
So
can
you
still
want-
see it?
yeah.
Is she?
Can you still see it?
I can still see it, yeah.
Okay, good. Sorry.
Okay. Should I just continue or start with?
Just continue.
Okay. So I was going to say that Webster et al. 2005. They use a future projection. That is the warming climate to see if tropical cyclone will change with the changing of SST. And the results show that the intensity of tropical cyclones increased with warming climate. So other than that, the interannual variability of tropical cyclone is known to be strong in most ocean basins. So if we are looking at the TC activity, we should consider interannual climate variability such as ENSO and NM. So in the tropical variability, El Nino Southern Oscillation can be the most important one. And in the Atlantic region, the Atlantic meridional mode can also be really important. So the top figures shows different conditions during the ENSO events. So during the El Nino events, the Walker circulation will move eastward, and the thermocline in the Eastern Pacific will deepen and associate with anomaly westerly circulation, and then also warmer Eastern Pacific SST. And during the La Nina events, all the things are reversed. that we have a anomalous easterly wind and a sharpened thermal climate, which is associated with colder SST in the Eastern Pacific. So during the El Nino event, because of the increase of SST and so on, the TC activity can be more active in the Eastern North Pacific. And because through the changing of water circulation, the vertical wind shear can also be changed in the Atlantic regions. So the El Nino events tends to suppress the TC activity in the Atlantic region. And this is also the case for the Western North Pacific region. And in La Nina, during La Nina events, the impacts tends to reverse. And this figure is showing the NM pattern. And this is the maximum covariance analysis of SST and 10-meter winds. So we can think of MM as a tropical meridional dipole of SST. During the positive phase of NM, we have a larger than normal SST in the northern tropical Atlantic, while we have a lower than normal SST in the southern Atlantic regions. So during NM, we tend to have increased TC activity in the Atlantic region, but decrease in the Eastern North Pacific region. And it is reversed during the negative phase of NM.
Is this a positive case?
Yes. Even though the SST is really important for TCs, we have a really severe SST bias problem in our state-of-the-art models, such as CME5 models. So this figure is from one et al. 2014 paper, and this is showing the SST bias, the ensemble means annual averaged SST bias from 22 of the CME5 models. And we can see that there's a strong warm bias in both Atlantic and Pacific cold regions. And so Xu et al. 2014 point out that this biases persist from CME3 to CME5. And for example, the bias in the Atlantic can be as high as 6 degrees Celsius, which is not showing here because this is the ensemble means. And then other than these two warm biases, we also see cold biases in the northern part of both Atlantic and Pacific regions. And if we look at the Pacific region, other than this northern cold bias, we have a kind of secondary maximum bias along the equator here. So people have been looking at the causes for these biases, and the possible reason for the cold biases is from the errors in simulating cloud cover and the associated atmospheric conditions. And for the warm bias, people tend to think that it is associated with error in simulated thermal climates and wind-driven circulation in the ocean. So even though the causes have been studied, the impact of the biases on TC is still not well known. But we do know that the SST bias can influence the TC activity. Because, for example, Becky et al. In 2014, they tried to adjust the flux, the momentum, enthalpy, and freshwater flux to adjust the SST close to the observation. That means without biases. And they found that after they do the adjustment, the TC simulation is much better than before they adjust the flux. So this severe SST bias problem can hamper our ability to project future change in the TC activity. Also, to hamper the ability to do the seasonal forecast for TCs. And it can affect not only the main climate conditions in the tropics, but also climate modes such as MM and ENSO. And they are both very important to TC activity. So in our proposed research, we will try to establish a relationship between the both individual and combined SST biases and the simulated TC activity. And then we will try to investigate the impact of biases on the interannual variability and also the seasonal TC predictability by conducting several suites of numerical simulations. So the first question we would like to ask is that how do the Atlantic and Pacific biases individually influence the simulated TC activity and the associated environment? So this is the figure, the SST bias pattern we just looked at. So if we recall the MM we just mentioned, this Atlantic biases looks really similar to the SST anomaly during the negative phase of MM. And this warm bias in the Pacific Ocean is corresponding to the El Nino events, while this secondary co-bias along the equator is similar to the SST anomaly during La Nina events. So based on this this variability, we guess that we might see negative TC activity in the Atlantic regions caused by the Atlantic biases, and then positive TC activity in the Eastern North Pacific due to the Atlantic biases. And because of this warm bias, which is similar to El Nino, we expect to see a decrease of tropical cyclones in the Atlantic, while increase in TC activity in the Eastern North Pacific. And if we look at the impact of the cold biases, because this bias similar to the La Nina events, so we expect to see an increase of TC in Atlantic and then decrease of TC in Eastern North Pacific. But for the Western Pacific, if we look at this cold bias, we expect to see an increase in the TCs. But if we look at this paradigm, the cold bias, we expect to see a decrease in TC activity. So people tend to think that the SST variability in the Western North Pacific doesn't really influence the TC activity in that region, because the sea surface temperature is already very high in that region. So small variability doesn't really influence whether the SST can meet the threshold for TCs to generate, which is around 26.5 degrees Celsius. But this cold bias can be as high as -3 degrees. So maybe this cold bias can suppress the TC activity in that region at some level. So with the compensating of these two biases impacts, we're not sure what we're expecting to see in the Western North Pacific region. We also want to know that how do the SST biases interact between Atlantic and Pacific regions? How do they combine to influence the TC activity? So here we hypothesize that the combined SST bias of Atlantic biases and the Pacific warm bias will have the impact similar to concurrent phases of El Nino and negative NM. But we also need to consider the co-bias in the Pacific, which might be compensating the effect of the other two. Also, we do not expect to see a linear combination of all the biases impact from both Atlantic and Pacific regions. And the second question we have is that how sensitive is the arrow in simulated TC activity to SST bias amplitudes? What is the target improvement in the simulated SST that we would need to achieve to produce significant biases in simulated TCs? In other words, what percent of SIMI5 models produce SST bias that are small enough that we don't have to consider it when we do the TC simulations? Also, is there a relationship between SST biases and the TC activity linear? So this is from Richard et al. 2014 paper. And this is showing the SST along the equator, averaging from 2 degrees south to 2 degrees north. And it's in Atlantic regions. So the left panel shows the SST from SIMI5, while the right panel shows SST from SIMI3. And the black lines here are the OISST. So we can kind of see that the spread of the ensembles kind of decrease from SIMI3 to SIMI5. But if we look at individual models like this one, the bias can be as high as like 4 degrees. Yeah. And also this spread of ensembles has seasonality, so we also need to consider this. Another thing is that people have found out that there's a correlation between Atlantic co-bias and both Pacific warm and co-biases. They have a positive correlation. So when we try to answer the question that, for example, which SIMI5 models produce SST bias that is small enough, we have to consider co-bias and warm bias at the same time. And also this correlation has a seasonal cycle, so we also have to take that into account. Here we hypothesize that the severity of TC simulation errors is non-linearly related to the SST bias amplitudes. And our last question is that, do SST biases alter the impact of interannual climate variability, such as ENSO and M, on simulated TCs and the seasonal predictabilities, and by how much? And these figures are made by Chris. And they're showing A's on the left side and S in the Atlantic region on the left side and East and North Pacific on the right side. So we can see that climate modes such as NM and ENSO do vary the A's in the both regions. And that if we consider all of the cases, we can see the spread that is comparable to the observation. So in our question, we want to know that if we add in the bias to this kind of climate variability, will it alter the mean of the change of age? For example, if we add in the Atlantic bias, which is associated with negative NM, to the positive NM, will we compensate to each other and then have no change in the mean? Also, we want to know that after we add in the bias, will the spread, which is the internal variability change, will it be bigger than observation or very small that cannot cover the observation? So this is the question we want to answer. So for my proposed research, we will be using the tropical channel model, which is described in Chris' paper in 2015. I think it's 2016, sorry. And it is configured from the WRF model and the latitudinal domain set to 30 degrees south to 50 degrees north, which is shown here. And the longitude is along the globe. So because the longitude is along the globe, so we can include the tangent connection between different regions of tropical regions. And because we set the northern boundary to 50 degrees north, we can also include the tangent connection through the higher, like mid-latitudes to the tropics. And the model resolution is 27 kilometers in horizontal direction, which is TC permitting. And in vertical direction, we have 32 layers. Oh, and the sensitivity have been tested by Chris in 2014. So we see a weaker simulation in TCs and more number than observation in TCs, but the WRF or tropical channel model can simulate the ENSO impact on TC activity pretty well. So that's why we think it's a suitable tool for this topic. So for the runs, we're using the 6-hourly NCEP2 data for lateral boundary conditions. And the initial conditions will start in April, and we will use the simulation period from June 1st to December 1st, which is the tropical cyclone seasons. And the control SST will be used as the headed SSD monthly climatology. And the SST biases will be calculated from the SIMI-5 multi-models ensemble means relative to the OISSD. And the time frequency will be interpolated to 6 hours from monthly. And this is a figure showing the SST bias in the Atlantic region that we calculated. So we will use both positive and negative bias in our runs. So in order to answer the first questions, how the bias individually influence the TCs, we will have control run, which is not including the SST bias, a run with only positive bias and run with only negative bias and combine positive and negative bias, and then compare this for simulations. We will do this for both Atlantic and Pacific regions. And in order to know how the biases interact with each other to influence the TCs, we will have around that, including both Atlantic and Pacific biases, and compared to the control arm. And to quantify the threshold at which we can not worry about the biases for TC activity, we will altering the amplitude of the biases by maybe double or half of the biases, and to plot out the relationship between the bias amplitudes and the TC activity simulation errors. And to look at how the SSE bias will influence the climate variability impact on TCs, we will use idealized ENSO and RONS. And then compared to the control run and the combined bias run from this part. And we will also add biases on top of idealized ENSO and ROMs and see the combination of climate modes and biases and how they influence the TC activity. So after we do the simulations, we will use a TC tracking algorithm based on WASH 1997, and the code was written by Xiren Shan. And Chris have been using this to track the TCs in TCM. So for in order to be identified as a TC, there are several criteria that have to meet. And then after we done the tracking for the TCs, we want to quantify the TC activity. So the first index that we will use to quantify it is the accumulated cyclone energy, ACE, which is calculated from the summation of 6-hourly maximum sustained wind speed. And the ACE can account for strands number and duration. And the second index we want to use is the Genesis Potential Index, GPI, which is calculated from the absolute vorticity, relative humidity, potential intensity, which is a function of SSD and vertical profiles of atmospheric temperature and moisture, and also the vertical wind shear between 850 and 200 millibar. And to look at each term's contribution to the anomaly of GPI, we will be fixing other, for example, if we want to look at how the absolute vorticity influence from the bias run on the control GPI, we'll fix other terms for control values, and then put the bias value in this term, and then compare this bias GPI to control GPI. And here are some preliminary results. So we have done the individual biases in the Atlantic regions, and these figures are showing the ACE on the top panels and the tropical cyclones number in the bottom panels. In the Atlantic regions, Eastern North Pacific regions, and the Western North Pacific regions. And in each subplot, we can see the control positive, negative, and combined bias rounds. So it's not showing here, but if we look at this figure, we can see that the mean A's and the TC numbers both decrease in negative and combined case in the Atlantic region. And it is statistically significant. We use the student t-test and set up to 95%. And this is also the case for the Eastern North Pacific region, that we tend to have more tropical cyclone activity in both negative and combined rounds in A's and TC numbers. And they're both significant. And if we only look at the mean, there's no significant change from the positive bias round to the control. Or in the Western North Pacific region, there's no significant change in the mean. But if we look at the spread of the ensembles, we can see a dramatically decrease from the control to positive rounds in the Eastern North Pacific A's. And maybe in TC number, if we just look at the maximum and minimum numbers. Oh, so this box plot is showing the maximum and minimum values with the whisker. And then for the box, it is showing the median, and then 75% tail and 25% tail of the ensemble values. So we also plot out the results from only 8 ensembles, and this decrease in internal variability seems to be pretty robust. So in future, we will look at how the internal variability can change with adding bias in our rounds, especially in like positive rounds and the rounds in West North Pacific. So we use GPI to look at the spatial pattern of the change. And this is showing the GPI difference between positive, negative, combined bias round and the control rounds. So we see a negative anomaly in the Atlantic region in both negative and combined rounds, while we see a positive anomaly in the Eastern North Pacific in this both 2 rounds. So we would like to know which terms or which variables contributes to this kind of anomalies. So this is plotting the GPI trend contribution from the vorticity, humidity, potential intensity, and the shear. So we can tell that the negative anomaly in the Atlantic region is coming from the combination of humidity, potential intensity, and also the shear, while the positive anomaly in the Eastern North Pacific is solely contributed by the shear term. So a little summary on my preliminary results is that the Atlantic negative and combined biases can significantly change the TC activity in both Atlantic and Eastern North Pacific. The Atlantic positive bias doesn't really change the TC activity, but it can generate changes in internal variabilities. Also, according to ACE and number of TC and GPI, the Atlantic negative and combined biases decrease the TC activity in Atlantic and increase the activity in East and North Pacific. And the decrease of TC activity in Atlantic is contributed from humidity, potential intensity, and shear terms, while the increase in East and North Pacific is contributed by the shear term. And we need to do more analysis to explain the mechanisms. So this proposed research will be completed in 2 years. And this is the timeline. I will start with finish up, analyze the mechanisms of the Atlantic bias, and also do the simulations for the Pacific regions and the combined Atlantic and Pacific biases. And in this time frame, I will finish the first question and start to do the simulations for finding the threshold of the SST bias to not influence the TC activity. And then after finish it, I will start to run the last part simulations, and then I will try to write up dissertation and defense before May 2018. And that's it.
Okay. Okay, so the time is about right. So any comments and questions for Wei-Ching? Everybody follow? What
I have a few comments,
Okay.
so in the first part, when you're talking about the background and objective,
Mhm.
you have multiple slides, 1,
Right.
2, 3, 4, 5.
Uh-huh.
So it's better if you, so each of those background and objectives, right? So what happens is it's the background and objectives is a little distracting, whereas the focus of each slide is not very well seen.
Oh, you mean the title?
The motivation, the TC predictability. What you could do is you could make that as a main heading and put
And take
background
this
and
out?
objective somewhere in the lighter color or something.
Okay.
That is one thing. And in your research methods, where you're talking about different kinds of runs you're making, you put 16 ensembles each. It's not 16 ensembles. The size of ensemble is, I believe that's what you're saying.
Yeah, right.
other comments?
I kind of follow Tarun's suggestions. Like, so the initial few slides are full of text.
Yeah.
And especially if there are people who doesn't follow these acronyms and regions, you can show a couple of figures in every slide, and then label that region and explain the text. So.
Yeah, I have the same feeling too. It's just
So especially when you're
it's very
talking about
difficult to follow when you put so much text in.
Yeah,
in the
geographical
slide.
region, not many people know. You say Southeast Atlantic, they don't have a physical feeling for it.
And it's too long also.
Yeah,
The
especially
introduction
this-
is way too long.
Or you can show a map and identify the studies and like which region, what they found. So try to tell the story from a picture perspective. It's like especially in the first few slides, if you show the region and like geographically saying the region, this AMO region, you get a geographical perspective of that. Just by text, like 3-4 slides, then you will.
I think you can. I mean, what in the introduction, what kind of message do you want to send to your audience? What do you want to say in the introduction?
Why TC simulation is important, and what is the SST bias problem, and what is the relationship between the two.
Okay, so can you actually think about some showing a few published results, a few figures? highlights those importance
Okay.
rather than describing them in all those in very long sentences. I mean, for example, there are quite a few studies now showing how the projected TC is going to change in the future, right? So you can actually just show one slide, and based on existing studies, how the TCs are changing or potentially changing, right? And then you can, in terms of the potential seasonal predictability, and you really need to make send a message saying the reason we can predict, potentially predict the seasonal TC variability is because the TC variability is very highly correlated to the SST anomaly, right?
Yes.
And that really is the foundation for the potential for the seasonal forecast. If TC randomly occurring, there's no chance you can predict anything, right?
And I think along that line, that would be a good place to also discuss the importance of the internal variability. So you talk about that, but maybe I missed it, where you should probably say that the larger that is, the less predictability that we have. So there's this sort of balance between what we can get from the SST and what we lose from the internal variability in terms of the predictability of the TCs.
So I think it's just, I mean, I can follow what you are saying because I've been working with you for all those years, but I'm not sure how many people in the room even, that really can follow what you're trying to say. It's just you need to make a point very clear to your audience, and this is a motivation, and this is the reason you want to do this research, and then you can say that climate models, you actually show this nice plots showing the very large SST biases, right? So then you need to somehow connect in motivation, the main objective is that when you have such big biases, right, can we really use model like this, which is the model we are using to project future climate change, right? Can this kind of model, can we use this kind of model to project TCs into the future, right? And can we use this kind of model to do the seasonal forecast of the TCs?
I also got lost when you were explaining the impact of AMM positive, like there's on tabular, very big tabular, there are like almost 14 or 16 equations, if you think about it, that this does to this region, between the region and the different kind of biases. What you could do is, so you have a picture above it, right? You have SST biases. So you get some kind of, instead of explaining it from the tabular, you can also indicate, you can go towards that. So that's fine.
Like this one?
This one, yeah, that's the one. There are too many relations here to figure it out. You could point it directly to the figure that, for example, cold bias over this region, it will do something. Or you could put symbols on that in addition to that. You can put it on, you can write over those main figure, just to show it pictorially again, what Jason was saying earlier. Like I could follow the Atlantic and the negative and positive, but at some time it just like too many things to do.
Okay.
And color code actually, that will help. Color code.
Yeah, and then the argument about the cold bias, the narrow code, you're saying it looks like La Nina, which I'm not sure if this completely justified, right? I mean, if you're plotting the composite of, I'm sure it's not exactly like that.
Which fold bias are we talking?
You're talking a very narrow term
Like,
around the
That is
equator.
the vertical missing scheme involved with the.
Right, no, she's arguing this SST error, the pattern, this SST bias pattern looks like a code event, an Enso code event. That's what he's arguing.
The equatorial one?
The equatorial one.
Um,
It's too narrow.
So that kind of bias is typically coming from vertical missing scheme within the.
I know,
Right.
we know it's, but it's just mainly trying to arguing that speculating what this kind of a bias can do to
Oh,
the
okay.
TCs.
Okay.
So she's saying that because this code bias looks like a La Nina,
Uh-huh.
so its impact could
Uh-huh.
have a similar impact like as if you have a La Nina impact, right?
Okay, okay.
And so that's kind of the things, but I think, I'm not sure if this entirely is convincing. I mean, you have people in your committee who is expert in El Nino studies, who probably is not going to be happy to hear you say that, right?
Yeah.
So I'm not sure you can say to some extent it looks like, but I would not say that.
No, say similar to.
Yeah, I think the bottom line is that I don't think there's too much sense of speculating what kind of this bias can do. We just can merely say that there are lots of biases, and you're interested in find out what those kind of bias can do
Okay.
to the TC simulation, right? Right. So
And overall, that's only a small stretch in, like the attitude coverage. So I don't think it's going to have any major impact in people at all.
right. So I think here I would not spending too much time to speculate, whether this bias is increase or decrease. And you can say a few things, certain things, but there's some biases we don't really know.
So when we just mentioned several, like
Right, I mean,
Atlantic
there's several
biases.
things you can. For example, the biases in the Western Pacific.
Right.
Honestly, we don't know what this bias can do.
Right.
So I don't think it's really make much sense to speculate until we can find out, right? And that's part of your research.
Instead of that, you can, detail about the planned experiments. What kind of experiments you are planning to run, what kind of analysis you are planning to do, or which of these major problems you are planning to address in that sense.
Right.
That would be a more plan-oriented approach than speculating what's going on.
And then I think when you introduce those this model experiment, I'm wondering whether it's better, instead of putting all those in Word, I'm wondering whether you can actually showing this in the graphics manner. You can have a panel showing the chronological SST, right?
Mm.
And this is essentially your control simulation.
Right.
Your control simulation is going to be forced without any SST anomaly,
Right.
just chronological SST, right? And without any biases, right? And then you can, superimpose this chronological SST using a bias pattern, right? And this is one set of experiment. You're going to add SST bias onto the observed SST chromatology, and then you're going to compare this one to your control run to see how the impact is, right?
Mhm.
And then you can add another one in another region, right? You can say, I'm adding this in, this is my second experiment, and so on and so forth. So people then can understand visually, what are you trying to do, rather than writing all those words and
I think that's exactly what I was saying in the beginning, because now, especially now, everybody is fixed oriented, like all the smartphone applications, TV,
Right.
computer. So instead of telling something, if you show something that's much more, it's easy to follow.
yeah, I mean, you can use this nice feature in the PowerPoint, right? You can actually defining the path and clicking the thing and superimposing by one. I mean, that way you don't have to show all the things, but it's just showing a few examples, then people would understand what do you really want to do. Right? And then in the analysis part, I will not actually go into these details how you track the hurricanes and stuff like that. There's no need to show things like that. And unless your committee member is going to ask you, how you're going to track, right? Then you can show something like that.
Okay.
I think the point I'm trying to make is that you need to think what is the important stuff you want to say and what is not important stuff.
Mhm.
Okay, it's not like you want to show everything you have done.
Okay.
And you want to show enough results so that people get convinced that this is a good research topic and worthwhile to continue.
So is the amount of figure that I show in results enough?
I think you have enough results, yeah, but it's just, the stuff you show, it doesn't seem to bring out the amount of work you have done. That's the feeling I have.
Okay.
But you need to somehow, I think you have done lots of runs and things like that, but people don't appreciate how much work you have done because the way you presented the stuff, the other thing is that for the results, I actually like to see, instead of showing those the bar diagram, which is useful, right?
Mm-hmm.
But I think what you need to show visually, showing the track density change, for example, is much more effective.
Oh, okay.
Right? I mean, you can show your control simulation, and this is your track density simulated, and then you can add a bias to it, and you can immediately see how the track density changes. I mean, that kind of stuff people can visually really see. But for those kind of bar diagrams, and it's difficult to explain. I mean, unless you really are expert, understand. But those stuff is useful to showing some kind of internal variability in the spread and things like that. But those are more difficult things to show to the audience who doesn't really have much of feelings what's going on.
Mm-hmm.
I think you need to select the figure which actually can really send strong message.
I think also I would devote some more time to explaining the future work that you have planned. In particular, I think it wasn't really clear what simulations you were doing for answering the third question.
Mm.
So I would devote some more time to that.
Okay.
And then in terms of the predictability issues, I don't think we ever made the predictability issue really clear.
Mm-hmm.
Right? I think the whole point you're trying to make is that in order to understand the predictability, it's not enough just to finding the signal. The signal here is defined by SST anomaly for TC variability, right? And that's the part you can predict, because we can hopefully predict the SST change.
Mm-hmm.
And that presumably would actually drive the TC change, right? But there's also another part which is more difficult, which is internal variability, which give you the component which is not predictable, right? So you want to see how the SST bias can actually have an impact on the internal variability of the TC as well, right? Talked about that. Mm-hmm. So you need to come up with a definition how you define the predictability, which is really the signal, the ratio between your signal and the noise, right? I mean, if the signal to noise ratio is very small, right, then hope to predict is actually very small. On the other hand, the signal to noise is very big, then the chance for you to have a successful prediction is actually very, very high. Mm. And you never define such a concept. And that's why a lot of people probably didn't understand what you're trying to say. I mean, you have your title saying that you want to look at the bias on the predictability, but people don't understand what do you mean by predictability. So all those important concepts, I think it's really useful for you to define them very clearly. Okay. And that's what you want to do, and that's what you want to study, right? Mm-hmm. So anyway, I think there are lots of results here you presented. It's just a way of organized in a very clear way. People can see clearly. Right now, I'm wondering how many people in the group really can follow what your research as well. I mean, that's the whole thing.
There's a lot of detail. Like you don't need to tell all the details.
Right, unless your committee member asks you, you can have those slides in the back, right? I mean, if people ask you, how do you do that? How do you track, hurricanes or TCs? Then you can show the slides. But it's not something you want to show. Not everything you want to show. You need to show the important stuff. Okay? Chris, do you have any more comments?
Yeah, just a couple minor comments. If I caught it correctly, I think you might have said something about a threshold of 26.5 degrees Celsius for TC formation. And I would be careful about saying that because that number is changing. The SSTs are warming.
Yes.
And the other things, I send a comment to your reading your proposal too. I think there's at this point, what you're saying is that the SST bias can do this, can do that, but you never explain physically why, right? So I think you want in your presentation, and you want to make sure that this study is just not about how the SST bias can affect the TCs, right? I mean, those are the easy things. You can run the model and run the number, and here is the number. But that's not enough, right? What you really want to understand is that, why that's the case. For example, you go back to one of your slide. No, for your presentation. I think on your towards the end, you show that one of the GPI analysis. Go back to this thing's here. I mean, when you look the GPI analysis, the contribution from the shear, right? I mean, you can see on one side is positive, and the other side is the negative. Did you see that? I mean, why is that? I mean, it's almost like a cut, But the atmosphere normally doesn't do things like that, right? And the atmosphere normally doesn't like very sharp changes, but this change is incredible. I mean, your committee member might actually ask the question, why is the shear changing like this? How are you going to answer a question like that?
Is it something to do with the land in between?
That's not true. There is red points on the like the north side.
Well, the thing is that the vertical wind shear. Normally, people think the contribution of the vertical wind shear is the upper level winds, not the lower level.
So this is the lower.
So this is the wind shear.
And if you look at the observation data, I mean the reanalysis, plus a simple figure, the wind shear, although makes a positive contribution, but the pattern is much more shift to the central. But the central ocean, I mean, it's not allowed the coast so much.
But those are the things I think when you, I mean, I'm just saying that when you're doing your research, you always have this curiosity, right? I mean, that's the good virtue to be a good scientist, right? So you always question why. You're always finding things curious. You want understanding why, right? Mm-hmm. So those are the things you should ask yourself. Does that make sense, or did you make a mistake in your calculation to give you this kind of pattern, or this is actually real, right? So I mean, to me, this is just really puzzling. Because if the wind shear is essentially driven by the upper level wind changes, the atmosphere shouldn't see things like that. I mean, there's something really.
But in Chris' paper, she also plot out the GPI contribution, and the shear pattern looks really similar to mine.
Yeah, well, I'm not saying that you made a mistake, right? What I'm saying that we need to understand this. What I'm saying is that I don't understand this. How can this be? right? I mean, is that really indicating that maybe the wind shear is in this particular area is actually caused by the low-level wind change? I don't know. The low-level wind change, I might be able to understand because there are lots of orography. Although the low-level wind is 850, right?
Yes.
I mean, even at 850, you don't expect that kind of a.
So doesn't this mean that, so the way I'm thinking about it, what it says here is the wind shear, it contributes like, if it helps the, on one side, it
Right.
decreases
Exactly.
on the other side.
It's anti-correlation.
It's anticorrelated.
Yeah. So when the cyclone decreases in the Atlantic Ocean, it actually increases in the Eastern Pacific.
Okay.
In fact, that's something he's going to talk
And
about next
which is
week.
coming from the shear.
Yeah.
Which is coming because of the shear.
And that relationship itself is not really explained very well. The people normally relating that to the wind shear change. But why the wind shear changes in this manner? It could be the other way. I don't even know. I mean, the way we actually plug in the GPI, the way we do that is a little strange too, right? I mean,
Right.
we're actually holding everything else climatological value, and then we're only changing one.
Yeah, this is
or
not
something
even the
like-
share itself.
Right. So I don't know whether this is something funny the way we did this and give it this. So you may want to actually just plug in the wind shear itself and take a look whether the wind shear actually. I'd be really surprised if the wind shear.
Actually, I think I've done that in one of the group presentation.
I'm really surprised the wind shear was usually patterns.
Where is this one? No. This is the share itself.
Shear itself has a,
The shear itself also have something.
the shear itself has a,
Yeah, really interesting, right?
Mm.
And it does seem to have a pretty abrupt change as well.
Mm.
That's really curious. Yeah, I mean, I'd be really interested in it to find out why that's the case.
yeah, because if you look at the GPI definition, it just tells that it's square
Right,
V shear, so that shouldn't,
right.
somewhere it has to.
Sorry.
But anyway, I think the my comments is that in addition making your presentation more streamlined and think really hard on what is the important stuff,
Yeah.
what is not important, and then trying to add some interesting question to it, raise some really interesting points so people really feel like excited about this research, right? So I think that kind of stuff is kind of missing from your presentation. And trying to inject more physical argument rather than just say TC increase here, TC decrease here, and those are kind of obvious things to say, but what you really want to say is why that's the case. You really want to understand why. Okay. All right. Anything else? Okay. So if not, then end here, and I can talk to you more about your stuff. And Chris, you want to join us today, or you want to do that maybe later?
Sorry, we're having a meeting.
I think I want to talk to Wei Qing a little bit more about her stuff, but I don't know if you want to join us or not after this.
Okay. Yeah, sure. You're meeting now.
Yeah, not not in this room, maybe I'll go back to my office. We can turn on the Skype if you want to.
Okay.
All right.
All right. Yeah, I'll see you guys in a little bit.
Okay. All right. Thank you, guys.
Struggle.